I did put up the recording from Friday's class. I had to do it through my iPad. The computer was not working, which today wants to work. I don't get it. But please let me know if there was any issues. If it doesn't have sound, I apologize. At least we have the notes though from it. Today though, we want to continue where we kind of left off, but I want to make sure to do all the parts we looked at, right? On Friday, I said, hey, let's do these graphs. But I said, make sure on your own time to finish the domain, range, and determine if they're functions. Okay, hopefully one thing we can go through here is by the vertical line test, all 6 graphs we looked at represent function. All right, so we want to continue with that today. However, what I want us to get in the habit of doing is first and foremost, always identify. All right, that was something hopefully you caught on to when I was doing equations. What type of equation are we working with? And what does this tell me to do? So as you look at something like this, what type of equation would this be? Right, so that's one thing that we want to make sure we're comfortable with. With that said, we know that when we go to graph this, I should have a straight line. Okay, now as we go through this week, we're going to focus on linear specifically, and we'll talk about slope intercept form, and we will go in that detail. But today, just kind of more make sure we know it's linear, and we go from there. What is the domain of linear functions?
Okay.
Right. So do I need to graph it to know that domain? No, right? Because there's only going to be one exception. And at that point, the one exception will not be a function, right? When it talks about lines. That's talking about lines in general, though, right? So when we talk about linears, we're talking about lines. There is one exception, but we'll discuss it, like I said, as we go through this week. All right. But when you see something that's linear, you see y and x, domains, all real numbers. Is that clear to everyone? Now, with that said, though, I can then go and try to get the range from this, and we kind of start guessing, but what you're going to find is it's better to have a graph to get the range until we get higher levels of math, right? Once you get into, say, calculus, we have methods that allow us to know for sure what's going on with something, okay? But we don't need that right now. We need to be able to just know what is the domain, how do I identify it? What is the range, how do I identify it, okay? With that said, the next part, though, I said is to find the intercepts. Right, so how do I find intercepts? You could definitely do a chart. You can look at it from a graph perspective, but before we even get to the graph, because I don't have the graph right now, how do I get intercepts?
Your y.
Right, I want to plug in 0 for x and y, right? So we're going to say, hey, let x equal to 0. Then we'll go over here and say, hey, after I do that, let's let y equal to 0. Okay, 2 different processes here, but it's the same idea, plug in 0. If I get 0 from one of my variables, I know I'm on either the x-axis or the y-axis. Okay, so we plug in 0 for x, that'll give us y equal to 2 times 0 plus 5, which, hey, that works out nicely, right? And remember, you can always write that as an ordered pair. And I can go plot that point out right now. Nice thing about that, though, is since x is 0, hey, that's my y-intercept. That's how I need to put it on the 5 on the vertical line. Because that's our y-axis. Okay. The thing you have to be careful of what happens when we let y equal 0. Right, we're trying to find it, right? But how do I do it now? What is that process called? What are you trying to do?
Oh, see that.
Get x by itself. So before I just had to do 2 times 0 plus 5, right? Just simplify what I have. Whereas here now, I might have to simplify sometimes, where here we got to actually do the solving, right? So make sure you see the difference here that more often than not, when we go to find x-intercepts, we're probably going to have to solve. So this was our y-intercept. This will be our x-intercept. And remember, as we talked about yesterday, there are some graphs that have more than one intercept. Linear, we should not expect more than one. But as mentioned, subtract the 5 from both sides and then do what with the 2? Do we all still feel comfortable with that process? Now, when it comes to graphing, if I'm telling you to graph by hand on the test, am I going to expect perfection in plotting something like -5/2? No. Now, in the homework you find, usually you could find, it should let you go by half steps. So like if it's on Pearson, you should be able to get to pretty easily. just know that I would expect it to be close. So we're gonna put it right between -2 and -3. All right. If you ever get stuck with that, just ask yourself 2 goes into 5. Well, hey, 2 times plus 1 left over. So that's where I got this. Okay. With that said, though, what do we do with the 2 points once I get here? All right, so I found my intercepts, I got the domain, I want to grab the function. So do I need more points? Not technically, right? Because what are we drawing right now? Straight line. So as long as I remember that, I can go ahead and just draw it. All right. So I have this line that's going through both of those points. Now, if you need to, feel free to plug in more stuff, right? We plugged in 0 for x. Go plug in 1 for x. Plug in -1 for x. Right? There are other things you can plug in that help us out as far as knowing what the graph should look like. All right. But if we plug in just picking on -1, you get 5 minus 2, which is 3. And if you look at that, hey, that's where we're at, is at 3. Okay, so keep that in mind. You didn't have to work with the fraction, but thankfully it lines up the way it should. All right, any questions about getting that graph? All right, so make sure you understand for the test, if I tell you to find and plot so many points, that's what you should do. But on a homework, how many points is it wanting to use for lines? Only 2, so keep that in mind. Just pick any of the 2 points you have and plot them. Quadratics, it's going to be 3 points, and cubics will be 3 points. Beyond that, every other graph, from what I understand, is 2 points. Okay, so keep that in mind. Are we done with this though? All right, the last thing I asked for here is the range, right? So we got our domain. What is the range of this function? We all good with why it's all real numbers? Now, is it okay that I called it a function? So if I take that vertical line, I drag it through the equation, there's never going to be a place where it hits what?
Twice.
At least twice, right? Once it hits 2 times or more, we're done. So here we see, yep, it definitely works. So I do have a function. Okay. Now, see here, I put y equals though, but with it being a function, though, that we can write it another way. But before we look at that, is there any questions about getting this information from what we worked on? All right, so let me make sure I wrote the same. Yep. So here we see I'm taking it now, I put in function notation, we confirm that it's a function. All right. The first 2 points we found though were the intercepts. We let x equals 0, y equals 0, and that was for the purpose of finding intercepts. Okay. As we talked about last week though, we could plug in expressions as well. All right, so here's 2 expressions. Let's make sure we practice plugging them in. With that said though, what does this one represent? Does anybody remember that? Why is that one something we need to know how to do? Not inverse, no. That's going to look different. It's going to have similarities, but definitely look different. Symmetry, right? This is us just testing for symmetry. What we're saying is go change the sign for every single x value, is what that means. Take the x value and make it the opposite sign of whatever it was. And we want to see what happens when we take the left and make it the right side or vice versa. Okay. Now, with that said, just remember, all you're doing is plugging it in. We're taking that and we're saying, hey, this is 2 times -x plus 5, which is -2x plus 5. There's not a lot of simplification. That's the good news. However, be careful with your negatives as always. But also remember when you get here, where should we be looking? Back to the original. So is f of -x equal to f of x? Everyone see that they're not the same. So what you would say here is f of f is not even. You don't need to write it all the time, but that's what it means. And even, if you forgot, is symmetrical to the y-axis. And so if we go back to what we talked about the other day, like this would be an example of something that's symmetrical to the y-axis. Right, the left and right side are the same. All it is a different value in the x as far as the sign, right? Instead of 2, it's -2. Quadratics. That would be another example of where the symmetry aligns directly with the y-axis. But what was this one? Does anybody remember? Well, I kind of wrote it there, but if you have even, you could also have odd. If you remember, we could actually flip this one and it'll look the same. Okay. So if it's not even, the next step is to see if it's odd. What can I do to this to check if it's odd? What's the only thing that's changed? The negative, right? So understand that when you get here, just remember that, hey, when I get to this point, factor out a negative. I always like to just put -1 in the front, parentheses, and then change all the signs. Because what we're seeing here is this the same as the negative of our function? By factoring out the -1, though, all you need to do is look here. So is this the same as our function?
Oh, no.
Oh, right. So the first part, hey, the -2x doesn't work, but now the 5 doesn't work, right? So understand that as we can see here, that this is also not odd. So there is no symmetry as far as dealing with the y-axis is concerned. Okay. That doesn't mean a graph can't have symmetry as we talk about with quadratics, but it's not to the y-axis or to the origin. So we would say it's not even or odd. Okay. Now, the reason why we like that is we work with functions, and we'll see this especially with polynomials. That makes it a little bit easier to work with. If you know that something is even or odd, all you need to do is focus on positive values and copy what you find over to the other side. You cut the work by half when you recognize something follows symmetry. That's why we like it. Okay, so keep that in mind. Now, what was this next part for? Because that's another important one. We're just plugging in an expression. Hopefully we're paying attention that, hey, I can do the same thing we just talked about. Oh, x plus h, right? This wasn't necessarily something random we're working with now. I gave it to you as just an expression at first, but I showed you that, hey, as we work with this, it's going to have meaning for us. It's something that we can use with what we call the average rate of change. Okay. What do I do here to simplify this?
Distribute.
And all I can do here is distribute. Is everyone in agreement with that? After we distribute, though, there's nothing left to do. I'm stuck here. Okay, but remember, as I said, that there's a reason we do something like that, right? F of -x, its purpose is to check for symmetry. Right, here I'm just introducing it, but like I said, when we get to polynomial functions or rational functions, that's where we're really going to start seeing where it's useful. Okay. Any questions though with simplifying? All right, so we're okay with getting to either of these places. All right, so the next step then is make sure that we do the whole difference quotient. This is what we call the difference quotient, and we definitely want to be comfortable with it. All right. But remember, the difference quotient is just the average rate of change. It comes from that idea as we talked about y2 minus y1 all over x2 minus x1. And this is where we built up the idea of how a function being increasing or decreasing or constant. If it's increasing, the average rate of change is positive. If it's decreasing, the average rate of change is negative. And remember, constant then is left over with that 0 that's in between them. Okay. Now, the difference is now we're using function notation and we're saying, hey, take your original function and just any other point. That's what x plus h means, just any other point, just not the same point. It's important, though, that we make sure to remember h cannot be 0 because that would put a 0 in the denominator. Okay, that's why we know it could be any other point we want to use. Now, this is where it's helpful. Just remember that we did some of the work already. Because as I mentioned, the first thing you should always want to do here is go find that one piece we don't have. We have f of x. F of x was given to us. All right, so we need to go find the piece that wasn't given. As we did that work, that we said 2x plus 2h plus 5. If you need to, write out that work again. Once I get that though, we can now plug it into that fraction that we're looking at up here, right? We could say, hey, I have f of x plus h now, I have my f of x. Just make sure to put it all over h, so we'll have two x plus two h plus five minus two x plus five all over h. What's wrong?
Under the parentheses. So you distribute the negative.
So I forgot something. Right, why is that important? What are we subtracting? But we're subtracting the whole function, right? So make sure you see there, that's a good catch, right? That it should end up affecting the 5 too, right? It shouldn't be just the 2x. So the parentheses here are very important. Okay, so I put both pieces in there, but understand technically we should have parentheses around both of them. But we're not multiplying anything with the first one, right? Only the second one is dealing with the distribution of that subtraction. So make sure you're careful with that. It is very important. But how do we catch this error if we forget to? If we forgot to do that, how do we catch it?
Like 2x and negative 2x.
So a lot of times people get the 2x correct because the subtraction is there. However, that 5, if you don't have the correct sign in the 5, that won't happen. We don't want 10 right now. We want 0. Do not want 10. The nice thing about linears, as we talked about though, that division works nicely too, right? All I had left was the 2h. And then when you divide out the h's, we get the 2. Okay. Any questions with that one? Now that's one of those problems where it's just you gotta practice it. That's like, as I tell you, even if you have to do like 4 more, even if you get the first one right, just practice it. Make sure you look at that old exam. I have to make sure to publish it. I don't think I published it. I'm trying to catch up with that. But make sure you look at that practice exam because difference quotient is definitely going to be on this second exam. Okay. Make sure you also see here, if I give you any linear equation, we can write it like this. Y equals mx plus b, where we have a coefficient on x and then some constant value. Okay. I didn't use a though, because as we talked about, we showed that that 2 is going to be the direct connection to the average rate of change, or as several of you mentioned, we're going to have what we call the slope, right? But what I want you to see here is we can go through and call this a function, and we can find the average rate of change of every single linear function, right? There is no linear function we can't do the average rate of change on, right? So we come over here and say, hey, f of x plus h minus f of x all over h. We'll have m times x plus h plus b minus mx plus b. So instead of breaking it up, I just plugged it in from the beginning. Make sure you see here, though, from the x plus h perspective, we have to distribute that m. We did the 2 just now, so that was similar idea. Just an m now, because I'm saying it's any linear equation, right? Not just the specific one we looked at. Minus mx minus b, which again, we really like because now we have an mx and a negative mx, a positive b and negative b, gone, cancels out to 0. And then we're left with that, not 2, but mh over h will give us just m. Why? Was that a lot?
Yes, that's a lot. That's a lot.
You want more?
I said it's a lot.
Because, but you have to get to the point of making sure to break it into steps though, right? That's why I like to write this by itself. Break it up, try to keep it separate on your sheet then, right? Go off to the side. Hey, I'm doing this because I don't know what f of x plus h is. Then a space and work it out. I'm putting everything in one slide rather than a sheet of paper, so that doesn't help. But try to space it out there, okay? Especially when we get to a quadratic, right? Because the quadratic is going to have more work when it comes to dealing with this right here itself. So we definitely want to be careful with it, okay? The way you write it probably will help you then. Like I said, so try to in your notes, just like, hey, put this by itself and then go 4 lines down and do this part. So that way you can see, okay, I did this for this purpose, and then, hey, this is me bringing it all together. That help a little bit? Now, are you gonna see it looking like this all the time? No, right? Why did I use M and B?
That's a
Yeah,
big slope.
but you see, I use just more letters, right? Now, the reason here is me saying any linear equation, any linear function. That's why I did this way. And then this is very important because as we talked about, that means the slope is always going to be that M value. That's our coefficient of x. Right? And it doesn't matter what 2 points we pick, right? The average rate of change is always going to be the same value throughout the entire linear function. Okay. I did it more for the purpose of just practicing, hey, plug this into the function. Make sure you subtract the function correctly to show that. Now, as far as tests are concerned, expect something like this one, or like I said, usually a quadratic is used. I would definitely expect something with x squared. Okay. Now, with that said, though, let's look at some other functions real quick as far as graphing, and then we'll be able to jump into linears, like I said, moving forward. Hopefully what you'll see though is write these 3 functions down. I try to keep the notes exactly how we started the first one. All right, we did a linear. Let's identify these 3 and let's get the work domain and everything for them as well. So the first function, what type of function would we call that? All right, so making sure we recognize absolute value is something that we have worked with quite a bit, right? Now, with that said, what is the domain of an absolute value function? Is there any number we cannot take the absolute value of? What's the absolute value of -5? Right, now we have to be careful because, right, it won't equal a negative number, right? But the absolute value of a negative number is its opposite side. Okay. So negatives are fine, positives are fine. What's the absolute value of 0? 0 is fine. Now, the only concern would be like, what if I threw an I in there, but are we going to be working with I when it comes to graphs? No, right? So all we're worried about is real numbers, right? So make sure you see here that, hey, the absolute value is not one of the ones that I have a restriction for input values. Now, what you could take away from what you said, though, is that was the fact that, hey, my range might be restricted, though, right? That's important because if I do like the absolute value of 7, it's equal to +7, not -7. So there are some restrictions, just not for input, right? Domain is one of the ones we focus on first because it says, hey, what can I plug into this? Or more importantly, what can I not plug in? Okay. With that said, though, what was the points that we said to find? My intercepts, right? So let's go find my intercepts. What's the first one someone wants to do? What do we plug in to find intercepts? Plug it in 0, right? So does someone want to do x equal to 0 first or y equal to 0 first?
X.
All right, so let's do that. F of 0 equals 0 minus 3, right? Now be careful here because we're working with absolute value, right? So when we say f of 0 equals absolute value of -3, the result will be +3. We can go plot that point out right now. Well, what that leaves us with now is to go say, hey, when does y equal 0? So I gotta set my function equal to 0 and solve. When it comes to solving absolute values, though, remember there was two things we worked on. First, make sure the absolute value is by itself, which we already have. But how many solutions should I have with this absolute value? 2. Now, with that said, it would be x minus 3 equal to 0, or x minus 3 equal to -0, right? Do I need this second one though?
No.
No, right? It's probably better to write it out and just scratch it out, like, I don't need this right now, than to forget how to handle it, okay? With that said then, I only get one solution, right? So I can move here and plot that point out. And how do I draw my graph? Like a straight line?
No.
No. Definitely should be a straight line, right? Because it's not linear. It's not a side view. We've already called it a function, right? So that was my hint there. It's a function. Right? So we can go back and remind ourselves it should be what shape?
V.
A V, right? So that's what we looked at on Friday with that. Hey, we should have a V shape right now. But here's the tough part, right? Is how do we handle it when it's x minus 3, not just x? Okay. Well, what we need to do is go find more points. All right, we got to go find more points. Now we've already set the thing equal to 0, so let's focus around that part of it. Okay, let's focus around the x-intercept. Okay, with that in place, then what we need to do is go plug in, say, f of 2 and f of 4, just to see what happens. And when we do that, we get 2 minus 3 and 4 minus 3. But the absolute value of -1 and absolute value of +1 both equal +1. Okay, so remember all I did was up here, take that value, subtract 3, so that's where these are coming from. But the absolute value of both those give me 1. So if I plug those points in, we get an important part of our graph now. A change of direction is what the key is here. Now, you could go find more points if you want. Remember, as far as those points, we typically focused on these 5 points so far. -2, -1, 0, 1, 2. But we couldn't use those 5 right now because guess what? I have absolute value of x minus 3. It's shifted my graph a little bit. However, it's still what shape? It is still a V shape. How far to the right did it move? We focus on kind of a key part of that V shape, right? Where it turns, how far to the right did that get moved? Remember, this was the function we looked at Friday, right? And if you look at what happened here, it went 1, 2, 3 to the right from what we looked at Friday. Is it a surprise that it went 3 to the right, you think? Doesn't that kind of give us a hint? That's one thing we definitely want to keep an eye on. Now, our main focus here was just make sure to get the graph. Intercepts are usually going to be the quickest points to get. But like I said, once I get there, I usually try to focus around my x-intercept first. Okay, that's not always going to work, right? You're going to have to plug in both, but that's where I usually like to focus. Okay. The other thing is like trying to get as close to that 3 as possible would be another great way to say I plugged in both 2 and 4, which are just above and below 3. Okay. Any questions with how I'm getting to this graph though? All right, and the last thing then is what is the range? So we're going from the bottom to the top. So we don't want to use anything below here, right? So we're only going up from there. Now the key is when you say 0 to infinity, what symbol should I have in play?
Right.
Right. This is my range, right? This isn't increasing or decreasing. The domain and range is the value used or is the value not used. That's all we're care about. And that is definitely a part of my graph. Okay, that's why we need the bracket. Questions, concern? All right, so the next one we had here is what type of function is. We go back to. So we have a quadratic, remember, polynomial. The big difference here is where absolute value had that sharp turn. Remember, our quadratic has that smooth term. Instead of a V shape, we should be thinking what? All right, it's called a parabola, but a U shape is usually a great way to just kind of remember the distinction between the two. All right. Hopefully, one thing that you're comfortable stating right away is that, hey, my domain is all real numbers. All right, as far as quadratics, it's just squaring, right? So I can square negative, 0, and positive. There's no restrictions there. What are the two functions we have restrictions for then?
Say that again.
There's two functions that we say we have restrictions for that we looked at.
Absolute.
The absolute value, we didn't have a restriction, right?
Oh, no.
So we looked at linears, we've looked at quadratics, any polynomial like you'll see here with x cubed, we're good. But on this slide here, what were the two functions that had x values I could not use? Not a cube root, what
What
do
was
we
that?
call it? Not a cube root, but a square root.
You
Just making sure. But it's important because a cube root, you're fine. So that's why I'm gonna be careful, right? So the square root we can't have. We're not plugging in negatives, right? What is this called? When x is in the denominator of a fraction. Rational, right? If it's rational, the denominator can't be 0. So those are our two restrictions we watch for. If we don't have that, we could say, hey, domain's all real numbers until we reach one of these situations. Is that clear to everyone? So when we get over here on a quadratic, we constantly say, hey, all real numbers and start moving forward graphing. Okay, the range though, hey, I got a U shape. I need to go find whether this graph has a minimum or maximum value. Okay. To do that for us right now, it's just plotting points and figure out what's going on. So just remember though, the first points we wanted to find right now were the y-intercept and the x-intercept. Now, hopefully you see there's 0 plus 2 is 2, and then 2 squared is 4. So I have my y-intercept there. Now with the x-intercept though, remember that we're setting this thing equal to 0. And as we saw, I have it set up to where I don't have to add or subtract anything. The squared part is by itself. What should I use to solve though if I already have something packaged in that squared with parentheses? You can't double it, but remember, as I told you on the first test, you can solve it that way, but as I go through the statistics, and we can look at this test right now, all of you go to that problem, if you did not use the other way, I don't think anybody got it correct when they doubled it up. All right, we have to remember here to use square root. There's nothing wrong with doubling up. Now you just have to remind yourself that if I'm going to do this, I need to make sure to follow my steps correctly. Here you should hopefully catch on. You could have just factored because it's already equal to 0. So double up, set the factors equal to 0 and go. But if you double up and multiply it, hopefully you try to factor it, or if not, use the quadratic formula.
Mm-hmm.
The problem is the people that tried to double it up on the test 1, you made a mistake somewhere in the arithmetic and it messed everything up afterwards. And I was not given partial credit a lot on that problem if you did not do it the way that we discussed in class. I gave some, but not a lot. So keep that in mind. Now, again, here though, do we have plus or minus 0? There's such thing as negative zero gain? No, right? So this is just another situation where we find that, hey, I'm only gonna get one solution, because the zero, I don't even really need it. Once I subtract two from both sides. But remember here, that is now an x-intercept. But we're kind of in that same situation we just found ourselves in, right? Tempting to, oh, let's just draw a straight line, it's 2 points, but remember, hey, this is quadratic, I should be expecting u. So what are some values someone would plug in here to help them out? And what? Positive 2? I don't see anything wrong with 2, but I would say try to focus more on the points you have. Right? So the only thing I would say is let's plug in -1. I personally would use -3 and -1, but there's nothing wrong with -4. So let's make sure we see that. What's -4 plus 2, y'all? -2, right? So when you plug in -4, you get -2 squared, which is +4. Which there should be no surprise there, because that matches up with the point that we already had, right? At that point, technically, you can draw the U shape. You have everything you need. Right? Now, the reason I like plugging in -1, though, is that you see it's definitely a U, not a V at that point when you get here. Because when you square that, we're going to get 1. And the same thing would be for -3 if you chose -3. All right. So as we deal with that, we'll definitely be able to see that, hey, this is that U shape we've talked about, not a V shape. I can draw it out like that.
So you input, okay, for G of -4, you put -2.
What's -4 plus 2? I did just like the previous one, do the addition first, that way, yeah, so just remember I did this first.
Yeah.
That's where the -2's coming back. And down here, that's where the 1 came from, right?
Yeah.
-1 plus 2. There we go. And for the sake of space and time, though, I kind of condensed it. Now, the only thing we have left here then is to find the range, but hopefully what you're seeing here is, U shape and V shape, there is strong similarities. So we could say 0 to infinity, just like we saw before. Now, keep in mind, though, you can't reflect the graph downwards, right? So right now that U shape is going upwards. But if I apply some negatives, right, change all those positive numbers to negatives, I can reflect it downward. Okay, to see what will happen. Where did we talk about that? Well, guess what? This right here is us kind of using a reflection to our advantage, right? Let's see what happens when we look at this from a mirror, right? Change all those values by applying a negative. So keep that in mind, that that's one example of a reflection that we use for a purpose, right? Just to see what would happen. Okay. Now, as far as dealing with this graph here, just know the range, the main thing I want you to hear for this is that the range could change based on it. Okay. Now, with the last couple of minutes, though, we do have one more graph. The main thing that we need to see from this graph, though, is the identifying point. What type of graph is it? Square root, which means we have a what involved? What is going on that we have to remember? What do we not want to have inside of a square root? Right, we don't want complex numbers right now, right? So we're saying, hey, this better be non-negative. Now the square root, especially because I use an inequality, right? I can have 0 in any positive numbers. That's where we see this. With that stated, though, make sure you know that you're stating your domain. No negatives. The other thing here is then I go from here and try to find intercepts. Know that you have to be careful because of what's going on. You're not always going to have one, but let's see what happens here. And look at that. We do have a y-intercept. So not always going to have one, but I do have one now. Also be prepared, you're dealing with the square root. Some things may not work out as nice, right? X squared the same way, may not always work out nice. Setting the function equal to 0 gives us our x-intercepts. All right, so make sure you see here though, we had 2 minus the square root of x, so I add the square root of x to both sides. What can I do once I do that? How do we get rid of the square root? Square both sides, right? So we'll get 4 equal to x, and guess what? We actually have an x-intercept too, right? Now, this is a tough one as far as plugging in points though, because you'll find we wanted certain numbers here. The nice thing about 4, the square root of 4 is 2, right? What's another number we could plug in right now that would work out nice? We could definitely find 9, right? H of 9. Also remember you can do H of 1. The one thing do not forget is that 0 is a perfect square. We already have that point though, right? Because we plugged in 0 already. So we don't need to worry about right now, but imagine I put it like I did here, x plus 2 inside the square root. Okay, so keep that in mind. With that said though, if you plug in those points, you should get something that looks like this for your graph. Okay. This range does get a little weird because what you're going to see is it's actually negative infinity up to that 2. Because it's going downwards from where it starts. But keep in mind, this is a terminal point. And when we look at that point, the domain and a range capture that point. The one thing though I would take from this right now is, hey, square root, I started my restriction, which actually gives me my domain. That gives me my domain. Okay. From there, just be ready to solve different types of equations. But as we finish up today, keep in mind that being comfortable with identifying the domain, identifying the range, increasing, decreasing inside of that is something we need to come to with the different types of functions that we're working. Keep that in mind. That is the end of class. We're at 10:49, so have a good day, and I'll see y'all tomorrow.
You said I was working right ahead of y'all, but and you said it was supposed to be do